My name is Ardius Zeradar, and you're watching the Ardius Zeradar Show. Last episode I announced that I would expose the flaws of academia's worst mistake, the field of modern psychology. I begin today by examining one of psychology's first principles, science. Humans find the study of psychology compelling because psychology claims to be a science. Humans have an odd belief that if something is science, then it is infallible. First, that assumption is wrong. Science is indeed fallible. Second, psychology is hardly real science. On its best days, it is pseudoscience. On its typical days, it is dogma. So, let me first address the belief that science is infallible. So people seem to hold this belief because of the products of science. Automobiles, computers, space travel, artificial intelligence, so forth. These inventions tell us that the modern human species is greatly more advanced than the idiot Neanderthals of the past. Idiots like Shakespeare and Plato and Aristotle. That's the claim, at least. At least that seems to be what people seem to believe, is that the ancient people didn't have the great advancements that we do. So these inventions are spectacles that leave us stupid with awe. Now, indeed, science deserves our respect. With it, we have accomplished extraordinary things. Its methods have forced people to think rigorously and methodically. And it's no wonder that we hold it in such high esteem. But the esteem in which we hold it is a bit too high. Science is not perfect. So first, I want to look at the kind of logic that science is built upon. So science is built upon inductive logic, not deductive logic. Deductive logic was the method established by the ancient Greeks, most especially by Aristotle and Euclid. Deduction is the highest form of logic. Why? Because the premises of a deduction lead to truth. If the first premise of a deduction is true, and the second premise of a deduction is true, the conclusion will be true, guaranteed. So, for example, consider the simple deduction. All mammals are animals. Premise 1. All right. Premise 2. Dogs are mammals. Therefore, dogs are animals. So you can see that as long as your premises are arranged in this way, and as long as your premises are true, your conclusion will be true. Dogs are animals, and that is most certainly true based on those two premises. Now, the Greeks were also adept at induction. They often use induction and deduction together, and I think actually that may be why I find their methods to be a bit more superior to the methods we're using today, is there was a real strong interconnection between induction and deduction under the Greeks. However, induction is inferior to deduction. If the premises of an induction are true, the conclusion might be true, but it could, in fact, be false. So consider this induction. Frank is a teacher. Frank is handsome. Therefore, teachers are handsome. Well, this conclusion is false. We know that not all teachers are handsome. Even if Frank is a handsome teacher, that doesn't prove that the other ones are. Even if several teachers are handsome, their handsomeness does not prove the handsomeness of all teachers. So the following induction is also false. Most teachers are handsome, therefore all teachers are handsome. In Aristotle's book, The Organon, Aristotle explains that logic can be performed demonstratively or dialectically. So we've been looking at this induction versus deduction, but there's also a second dimension. There's a demonstrative proof and there's a dialectic proof. A demonstrative proof is one built on known premises. A dialectic proof is one built on agreed premises. So though one might think that the demonstrative proofs are better, demonstrative proofs are often impossible because we don't actually have much knowledge and this is very clear from Descartes and the Matrix, humans don't really know anything about the material world. Therefore, the best proofs are actually dialectic proofs, proofs built on agreement and belief, not built on known facts. So, as ironic as it may sound, the Greeks, well, I don't know if they would readily admit this necessarily, but many of the proofs performed in the past were done based on agreed upon premises rather than known premises, and that sounds like a weakness. But I would assert that it's actually the better method, because I will certainly agree that there is a weakness there. The weakness of using an agreed upon premise is a lesser weakness than the weakness of induction. Because with induction, even if you have known premises, your conclusion can still be 100% false. So, good philosophers, they recognize their epistemic shortcomings. And they built theories on beliefs, not facts. And so the world doesn't put philosophers on the pedestal the way it does with scientists. In contrast to the claims built on deduction and belief, claims asserted by scientists are built on induction and so-called facts. But induction is vastly inferior, right, to deduction, because the premises don't lead to truth necessarily. And in fact, David Hume pointed out that no deductive claim is ever based on reason. Inductive claims are actually based on faith. I'll give you a brief example. I don't want to get too deep into David Hume right now, but Hume noted, for example, that your past experience of the sunrise tells you absolutely nothing about whether the sun will rise tomorrow. So you might exclaim, well, look at all the thousands of sunrises in the past. They establish a clear pattern and principle. We can therefore predict the motion of the sun based on these past experiences. But, on the contrary, you can only possibly show that every sunrise in the past established patterns about the past. You have no way of showing that the pattern from the past will continue into the future. That's a leap of faith. You might be able to show that the laws of physics existed in the past. So even all of our laws of physics, which we derive from induction, the only thing you can show at most is that they've existed at all times in the past. But you can never show that they will exist tomorrow. So your belief in past patterns is 100% pure faith. You cannot prove absolutely using induction. Now, I'm not making the argument that induction should never be used. Certainly it has its place, but we need to be aware of its weaknesses. And this is one of those weaknesses. Now, some assert that science is deductive. So let us for a moment say that the science... Well, okay. Some people... Yeah, I mean, this is an argument that I don't want to get too deep into right now. It's kind of an obscure argument. But there are some people that make the claim that it's sort of using proof by counterexample, which would be a deductive method. And certainly I will hear that argument to some degree. Like I said, I don't want to get too deep into it right now. But even if that's the case, that that's what science is supposed to be, I would argue that today science has really become in practice induction. It really is not deductive today, even if it's supposed to be. Further, science is not actually built on facts. It is built on a mixture of belief and sensory information. The failure of scientists to recognize this is pure arrogance. Science is not a system of facts. It's a system of beliefs. And as I just noted, beliefs and principles continuing into the future are beliefs, not facts. Consider the basis of science. The foundational presumption of science is empiricism. So empiricism is the claim that all rationally acceptable beliefs or propositions are justifiable or knowable only through sensory experience. Thus, the central premise of empiricism is that assertions not based on sensory evidence are invalid. However, that assertion refutes itself. And so I'm going to turn to the deduction of the day to demonstrate this. So let's take a look at our deduction of the day. So we start with our claim of empiricism. Claims not based on sensory evidence are invalid. All right, premise 2. Well, that very statement is a claim not based on sensory evidence. Therefore, that very statement is invalid. Right? The very core presumption in empiricism is a presumption. And it's a presumption that goes beyond the sensory world. So, by definition, in order to make the leap of faith in empiricism, you have to make a non-empirical claim. So by nature, non-empirical claims would seem to have some validity somewhere. At least one of them has to be valid, right? So I point this out to point out that science is actually founded on a belief. That statement is a belief, not on a fact. There are all kinds of assumptions and presumptions built into science. We might have, in these theories, we might have these particular instances of evidence, but you still have to have a major premise if you're going to create a conclusion. And your major premises, or you have to, for every premise, there is another set of premises to prove those other premises. And so you're going to have all kinds of premises existing based on belief. Unless your claim is, well, using purely inductive means, we can get to every single premise in our logical chain, in our paradigm. And that's certainly not the case. And if you examine science closely enough, you will find that that's simply not true. Let me give you one example right now, actually. There is a claim made by evolutionists, and I'm actually an evolutionist myself, and I actually believe in this claim. The claim is that we can prove the age of dinosaur bones based on carbon dating. So carbon dating looks at radioactive decay, and radioactive decay is there's a rate of decay in particular atoms, right? Well, we assume that the rate of decay is constant throughout time, but that is here's a clear example where we have a premise. Radioactive decay is constant, but it's not based on anything. There's no proof of that. And it's actually the creation scientists. So creation scientists are a group of Christians who don't believe in evolution, who point out this flaw. And, most of us look at the creation scientists and say they're crazy. I don't agree with the creation scientists in any way at all, for the most part. I'm actually on the side of the evolutionists. So I agree with the evolutionists that the claim here seems like a reasonable claim, maybe. But I am so grateful to the creation scientists for pointing out the flaw. Because if you're a wise scientist, you will listen to the creation scientists, you'll listen to the creationists, and what they have to say. They bring up a valid point. The rate of decay is constant. We don't know that. That is a leap of faith. And so scientists are making all sorts of claims and assertions. Their logic is founded on faith, on belief. So that, I think, needs to be clear. So why do I point this out? So partially I point this out to show that there's nothing wrong with using beliefs. Good philosophers will admit their assertions are founded on belief, but the problem is that scientists generally don't. Right? Scientists today arrogantly claim they produce factual information, and the world buys into it. The world believes that claims by scientists are inherently superior. And they'll say things like fact-based claims. I find this to be just horrendous and arrogant. It really is. And doesn't the Matrix prove the point that the sensory world is not factual? Right? The Matrix and Descartes All of sensory information is susceptible to illusion. It could be a dream. It could be a VR simulation. It could be, one of David Blaine's wonderful magic tricks. So any assertion that evidence collected from sensory information proves something about the material world, any kind of assertion like that is actually a belief, not a fact. So, science is not the only method, right? Scientists use rigorous method. But what about the claims made by geometers and logicians? Do they not use rigorous method? I find this to be fascinating that we just kind of overlook methods that we learned in high school. And these methods are rigorous methods. Geometry is a rigorous study. And it relies not at all on scientific experiment. In fact, there's not a single experiment done for geometry. Geometry is entirely deductive. And what Euclid accomplished in his Elements is he formulated an entire book and methodically proved every single conclusion, deductively. And that, to me, is a far more rigorous methodology than anything we use today in science. I assert that the deductive assertions made by geometers and logicians are superior to the claims made by scientists. I don't know. Why have you guys become so anti-geometry? Is science the only way? I think not. I think that science often fails. So scientists generally don't spell out their logic, and they don't assert major premises, minor premises, and conclusions. So, I don't know. There's a really dangerous, I think, reliance on science today. So my next question is, what is science? If science is supposedly something superior to other studies, then it must have something distinct to the other studies. Yes? If it just does the same things as philosophy, then it would not be superior to philosophy. Well, at least people have this notion in their heads that science is superior to philosophy. I'm not making that claim, but if people are making the claim that science has something inherently superior to philosophy, there must be something more rigorous and methodical about science. So categorization can't be it, because categorization was clearly explained by the Greek philosophers. Aristotle wrote an entire book called The Categories. So when we talk about categorization, that, I would argue, is not uniquely science or scientific. And so there's no reason why we should take claims of categories made by scientists to be elevated claims. And I'm going to come back to this later, because this is really important. People are doing this a lot now, where if there's a scientific term, so for some reason we think it has elevated stature of some kind. But those categories were not determined through experiment, because I'll go into it in just a little bit here. I'll show that categorization is not determined by experimentation. So categorization cannot be what makes science what it is. Most people say that what makes science superior is the scientific method, and indeed, I think that makes more sense. Right? The thing that makes science what it is the scientific method. The heart of the scientific method is really the key. And what is the heart of the scientific method? Experiment. But more precisely, the heart of scientific method is the correlation between an independent variable and a dependent variable. When you move the independent variable, you test to see if the dependent variable moves as well. This apparently proves a causal link. As a brief aside, I would mention that there is a thing called the flaw of causation. David Hume pointed out that causation can never be proved. So scientists are actually making a claim that is exaggerated here. Therefore, to be more accurate, I would say that scientists don't prove a causal link, they prove a correlation between independent variable and dependent variable. Don't forget that this correlation is proved using induction. In other words, based on David Hume's conclusions, the correlation cannot actually be proved. But let us say that they do prove this correlation. That's all the experiment proves. It cannot prove the existence of a category. It cannot prove the definition of a category. Categorization is not the function of scientific method. The function of scientific method is simply to show one thing, and one thing only, really, the link between variable A and variable B, the independent variable and the dependent variable. Finally, that the correlation is used to show a particular theory has been disproved or not disproved. Now, this I think is actually probably the strongest part of the scientific method. And by no means am I making the claim that the scientific method is something that we should throw out the window. No, the scientific method is a wonderfully rigorous method. And this is where I think its rigor lies, in this notion of trying to disprove a theory. Falsifiability is the term that they use, and a good scientist will point this out, that to disprove a theory with a counterexample, you've disproved the theory deductively. So there is certainly a sort of deduction built into the science here. However, if you don't disprove the theory, then you also don't prove the theory. And this is where I think we can run into some danger, because most of science is not built on the disproving of theories, actually. Indeed, we try to do that in the experiment, but the real thing that we try to do is to see if a theory can survive a series of disproofs. That's what scientists are really trying to do. They're trying to see if a theory can survive a series of disproofs. And to some degree, that sounds deductive, but it's not really. That's not really deductive. But a good scientist will point out that that's really the core of the method. However, most scientists are not good scientists. And what's happening today is most scientists will say that the experiment is proving. And that is erroneous, right? An experiment does not prove. If the experiment survives, then the theory survives, but it doesn't prove the theory. And this is an issue that arises in court actually quite a bit, and lawyers I think are far more aware of this than even maybe some scientists are. But when you fail to prove in court, that doesn't mean that you've proved the opposite. Failing to prove does not prove the opposite. In a similar fashion, when a scientific theory survives a scientific experiment, it doesn't prove the theory. It simply allows the theory to survive. And this is becoming dangerous, though, because the world is believing in the experiment so much that they believe that it proves. So even though this may not be the core precept of science, more and more this idea that experiments are proving is actually being treated like science. All right, so the last issue that I want to point out with science, at least today, there are other issues probably as well, but there is a thing called the peer review system. And we look at the peer review system and we say, oh my goodness, this peer review system, time and time again, people are citing to it as though this is a terrifically rigorous methodology. And to some degree, it has rigor and it has some methodology, but the level of rigor and the level of methodology, I would argue, it falls short of something truly deserving of pedigree. So the peer review system is the idea that every publication in science must survive a critique from peers. This notion to me is egregious. There's nothing mathematical about peer review system. What I mean by there's nothing mathematical about it, what I mean to say is it's not like some formulaic algorithm here. What we're really doing is it's a human system, right? It's a system of checks and balances. And, checks and balances between humans screams one word to me. Politics, right? When we're talking about checks and balances, I think of the founding fathers. I think of the Constitution. I think of republicanism. So we're no longer talking about science. I mean, the peer review system is a political system. Since when do we consider science to be about politics? Additionally, they use the word scientific consensus. Right? That refers to the majority. the idea of scientific scientific consensus blatantly commits two logical fallacies. One, argument from authority, and two, argument ad populum. In logic, we consider it erroneous to make an argument based on the idea the majority says is true. Is that not exactly what scientific consensus is? The idea that majority says is true, therefore it's true? I mean, that is a logical fallacy. We also consider it erroneous to make an argument based on credentials. But is that also not exactly what scientific consensus is? It's an argument based on credentials. It's an argument based on argument from authority. So it's committing two logical fallacies. Like, if you commit a fallacy, you've lost. Your argument has failed. So if the peer review system is a political system, then just like any government, it is corruptible. Since when does a system of checks and balances wipe out corruption? Certainly checks diminish the effects of corruption, but just look at American politics. It is hardly a system devoid of corruption. Indeed, some scientists have accused government agencies of purposely corrupting the scientific community. The National Science Foundation is a government agency. Do you really think it's not susceptible to corruption? Here at its fingertips are, I think billions, I believe it's billions of dollars. And using money, they can put forward certain research. Now think about this. If you're a political organization, if you're the government, government is by nature corruptible. You're a political system. You're by nature corruptible. And if you have money at your fingertips, you have power. And are you not then trying to promote certain areas of study by using that money? So, on the one hand, I'd say at the minimum, you're going to have certain areas of study flourish while others do not. That's at the minimum, though. But do you really not believe that you can buy conclusions with money? With enough money? I think you fail to understand human nature if you don't see that. Like humans, the one thing we've learned about humans throughout time is that they are susceptible to vast quantities of money. If you have money, you have power. And so if you have enough money, you should be able to buy scientific conclusions. And there are scientists who are making that claim. There are some scientists out there who are making that claim. And if you have not heard those claims, I would really press you to, really encourage you to research those claims. So we have proof that the peer review system doesn't even work. Scientists have purposefully submitted erroneous publications to the peer review system just to see what would happen. And what did they learn? Erroneous publications survive the peer review system. So why does the world seem to think that the scientific method stands above all of the methods? The system of deduction asserted by Euclid doesn't depend on peer review. The system of deduction asserted by Aristotle doesn't depend on peer review. Math doesn't depend on peer review, right? You sit down and you write you do some long division. You don't need to consult with some counsel on whether the long division is true or false. To me, that is real method. That's real method. And we've failed. I mean, we've abysmally failed to recognize this in our modern society, right? If you want to understand truth, you write truth tables. Logic is logic. Math is math. You don't consult some human committee. If you want to find truth, depend on those methods more than the scientific community. I would assert that deductive logic, geometry, and math are vastly superior methods to science. I mean, Euclid's Elements. Are you really going to look at? I mean, he wrote this fantastically beautiful book that he proves every single conclusion, every one of them, beautifully, in a more perfect form than probably ever done in history. An entire book of true conclusions based solely on deduction. He doesn't need the counsel of any other a group of scientists or committees. The proof is there in deductive logic. So in summary, I have demonstrated some flaws inherent in psychology today. I'm going to jump into many more flaws. But today, the central flaw I want to focus on is science. So I actually believe in science. I think science is one of our greatest inventions. However, we've invested far too much faith in science. Science does have flaws, and it is far from infallible. And I didn't have time to dive deeply into the flaw of induction and flaw of causation. Those are significant flaws of science. I might jump into those later, I don't know. However, I think I did sufficiently show at least that there's the center of the scientific method is the experiment the center is the correlation between an inductive variable and a dependent variable. I'm sorry, an independent variable and an independent variable and a dependent variable, right? There's a correlation between those variables, and that is really all you pull away from a scientific experiment. So in my next show, I plan to demonstrate that of the sciences. So sciences are pretty strong. They're very fallible in many ways. But of the sciences, psychology is the worst. In fact, it falls so short of science that it should not even be given the title of science. So deduction is at the top, right? Deduction is the highest level of logic. Some might say demonstrative deduction is the highest form of deduction. Below that is a dialectic deduction, which I might even argue is better than demonstrative because it admits to the flaws of human knowledge. Beneath deduction is induction, and induction is clearly the inferior because the premises do not necessarily lead to truth. If we go below induction, correlation, I would say, is even lower than simple induction. There's correlative induction, which is the lowest form of that induction. The higher form of induction, I'd say, is probably the scientific method, because it looks for some kind of causal link between the independent variable and dependent variable, but that in itself is susceptible to the flaw of induction and the flaw of causation. And of sciences, psychology is the lowest. So we are surrendering our society to this abysmally low form of thinking. And I am attempting to demonstrate that through these videos. My name is Ardius Zaradar, and good evening.